Hello, welcome back to es346 Basic Thermodynamics. This is module 3.3, Superheated Vapor. The section in the textbook is section 3.5. So here's the learning outcome for this module. At the end of this module, you'll be able to use the superheated vapor tables to find property values. Okay, let's draw up a phase diagram again and recall the different phases of materials that I have. Over on the left-hand side here, we have liquids. Underneath the curve, we have mixtures. And over on the right here, we had superheated vapors. And this is going to be the subject of here, are the materials that occur in this region. Now imagine, for example, look at a value of 200 degrees Celsius. And if I was to look at the superheated region, I'd have an isobar moving through there, but if I keep moving across, there'd be another isobar there, and another isobar there. So there'd be various pressures that all occur at 200 degrees Celsius. So it's not surprising that instead of having just one table of values, I'm going to have all sorts of tables of values that occur at different pressures. So that's the superheated tables. Table A6, superheated vapor. And so, for example, if I look at 200 degrees Celsius, I have a pressures at 0.01 megapascals, another table of values at 0.05 megapascals, and they all correspond to different lines of these isobars. So instead of there being a single table, we have sort of a table of tables. And it's not surprising because the saturated vapor line, the saturated liquid line, is a line. It's a one-dimensional line, whereas the superheated vapor region is a two-dimensional region and therefore would require a two-dimensional table. Alright, so finding property values is a little bit easier on the superheated tables because we don't have to deal with mixtures. We just need to find the proper table that has the properties we need. So the easiest way to do this is to look at an example where it's asked, what's the enthalpy of 2 kilograms of water? And I'm given a temperature and a pressure, 500 kilopascals and 300 degrees Celsius. So what I'm going to do is I'm going to go to the superheated table and look up 500 kilopascals. And in our table, we see that's at 0.5 megapascals. Recall, 500 kPa is 0.5 megapascals. I've excerpted the table from A6 here and indicated the columns that I have. There's a value of the volume, the internal energy, the enthalpy, and the entropy. And so since that's the 500 kPa, I'm going to go over to the 300 degree line, which is this one right there, and I can go ahead and pull properties right off of it. So if I want to find my value of H, where that's enthalpy, H is equal to, I see it's 3064.6. And my units are kilojoules per kilogram. Now if I want the total enthalpy of 2 kilograms, I'm going to need to multiply it by those 2 kilograms. So my total enthalpy, I'll use the capital H for an extensive property, is my 2 kilograms times 3064.6 kilojoules per kilogram, and that comes out to be 6129.2 kilojoules. I'll write that again, 6129.2 kilojoules. Okay, let's do an example that's not quite as straightforward. Here I'm asked to find the enthalpy of 2 kilograms of water, but I want it at 250 kilopascals and 400 degrees Celsius. 250 kilopascals falls between the two tables I'm given. I've got one here for 2.2 megapascals, which is 200 kilopascals, and 0.3 or 300 kilopascals. And I need a value somewhere in between. So what I'm going to do is use these values and interpolate. The basis behind interpolation is that I'm going to use my pressure, this will be the pressure at 250, minus the pressure at 200, divided by the pressure at 300, minus 200. So I'm going to do that. That will be equal to the ratio of the corresponding enthalpies. So the enthalpy at 250 minus the enthalpy at 200 over H300 minus H200. This is kind of the idea of similar triangles. So if I put these into this problem, I have 250 minus 200 over 300 minus 200 And that's equal to, I'll put my enthalpy below that. I look up what I'm solving for, which is H at 250 minus H at 200. So I'm going to go to my 200 table and look up what my H value is. It's 3277. And then H at 300, going over to my other table, 3275.5 minus 3277. And that will give me what my value of H is, which is 3276.25 kilojoules per kilogram.